Hello, my friends of Qatari Labs. My name is Saul Montoya. Please welcome to this webinar. The title of this webinar is Petroleum System, Geological Petroleum Modeling of a petroleum system with Gempy, Gemgis and Aquifer App. Okay, we are going to do lot of coding today. We hope, and actually there is no time for that, but we hope that you have downloaded the files. Okay, so if you haven't downloaded, Control C, Control V, you are going to see this in the description of the video. Okay, the password is Qatari Labs. You are going to get it and then just download. Okay, great. Once you have downloaded, please you have to place it under your documents. So here, this is box. Okay, so once you have downloaded, okay, so now I have it downloaded. I will copy from my download folder, Control X, and then I will paste it under my document folder. And then I will extract here. Okay, great. So if you have the folder inside your documents, please type 1 on the chat. And then we are going to open Anaconda Pro. CD documents, CD webinar, and then here you pick it. Okay, if you are here with me, please type 1. Okay, for the people that are recording, this is recorded, but it will be available. I won't, and I have a Patreon site. It will be available right there. Okay, and after 3 weeks, it will be available as a tutorial. So that is the question. That is the answer. Okay, so let's see. We have here a Jupyter Lab. Okay. And here we have a visualization in case, okay, if in case you don't have all the tools for the visualization, you have to install PyVista for Jupyter. Actually, I have already installed, so there is no need for that. And then we are going to open the model. Well, we don't have the model orientation of model surface, so we are going to start working on that. Okay, let's talk about something about the base reference. Okay. On the base reference, we have the horizon grids. So we have many raster files, okay, because we have the topography, we have the Neogene, the Paleogene, and so on. But we have 47 raster files, okay, that goes from the topography to the basement. And what we have is the top, okay, the top elevation. We don't have the bottom elevation, so that is why there is a small code that actually relates for example, for this layer, the Dawson Bay, okay, the bottom of the Dawson Bay will be the top of the prairie upper, So we have done something like that in the where we have done it in the P0, that is for formatting layers, for corresponding the layer with the bottom layer with the top of the underlying layer. Okay, so with that we get this master layer where we have for every layer what it will be. For example, for this layer Paleolene, yeah, the bottom elevation will be this one, Okay, and for this layer the water elevation will be this one. Okay, great. So let's start and let's create a new layer. Okay, let's have an overview of the codes. Okay, so here, okay, we open the horizon grids. Okay, we open the horizon grids. Okay, we actually apply, well, in this one, this is the bottom, this is the elevation. Okay, so we correlate for the we correlate for the layer, it will be the top of the underlying layer. Okay, and we create the master layer. Okay, if you see, we have 44 layers, but actually this is too heavy. Okay, this is too heavy as this is too heavy to be calculated. Okay, and even for the whole extension. Okay, why it's too heavy? Because we are going to plot this in QGIS. Because of the Gempy library and how it is made, and the computational resources. Okay, so it's quite intensive. So okay, so let's see. Okay, that's why we are going to work with a area of interest, and inside of area of interest there is an anticline that we are going to model. But we are going to model this anticline in Aquifer App. So let's see. Okay, here we start a new project, and then we are going to open the from documents. From documents. What are the document? Home documents. We are going to we go here, and then we open the raster file. For example, the topography. So this is the topography. Okay, great. And then here we have on the shapefile, we have the area of interest, and then we have the anticline. Okay, so we are only going to do the geological modeling inside this area of interest, but we are not going to model the 44 layers. We are only going to model 10 layers. Okay, so that's it. So let's continue to our next part of the code. On layer processing, well, we are going to use Gemgis, GeoPanda, Rasterio, Matplotlib, Rasterio Show. We open the OI, okay, to see the extent of our polygon. And okay, so, and then we get the length. This is in feet, so it's 312,000 feet and 367,000 feet. Okay, the extension. And then, okay, since we are going to sample, okay, since we are going to sample the okay, is my screen working? Please type 1, please type 2. Okay, since we are going to sample, okay, we don't want points that are on the border of we don't want points that are on the border of the okay, we don't want points here in the border, so that is why we are going to sample only from points that are inside, well, that are 10,000 feet inside. We do that just to assure, because the code actually doesn't work for points that are just on the borders. Okay, Let's see. Let's kernel clear all outputs. Okay, so well. Okay, so we sample that. We open the anticline. Okay, so and then we get the ordinates of the anticline. We also open the topo raster. Okay, we sample points in the area of the interest. Okay, great. Okay, so these are points inside the area of interest. These are points inside the whole area of interest, and then we add more points, but that are inside the anticline. Okay, then we do a plot of the whole and the points distributed all over the area of interest and as well on the anticline. Okay, so we join this and then we do a compose sample. Okay, and then we save the compose sample. We save the points of the area of interest and then we save the points for the anticline. Okay, we save that. Where are those saved? These are saved here as CSV, and these are the three arrays, the three saved arrays. Okay, great. So let's see for the part 2. Here on part 2, what we do, okay, we also import pandas, Gemgis, rasterio, geopandas. Okay, we open the layer, okay, but we only open from layer 20 to layer 30. Okay, we don't open the 44 layers. We only see because we are interested in this backend, because the backend is a layer that shows the anticline. Okay, so we open the area of interest, the anticline. We open as well the topography. Okay, and then we open the points, the composite points. I mean the composite and the ones for Nesson. Okay. However, okay, when you sample as well the surface, but you sample as well the orientation. What I found is that if you have more orientations, okay, the code is actually much slower. Okay, so that is why we only get 2 values of orientation. Okay, we are only going to work with 2 orientation because actually the layers are quite horizontal, so the orientation won't make that difference. But if you insert a lot of orientations, it will be very heavy. Okay, so we see the XY for the 4 selected points. Okay, for the 2 selected points. Okay, so these are the 2 selected points. Okay, so we open the shape file with Fiona, and then we get the shape. Why? Because we are going to clip. Okay, we are going to clip. Okay, so we insert the raster, we insert the model top. No, actually the model top is not doing nothing, and then we are going to clip the raster. Okay, just to for the area of interest. Okay, we are going to clip that in a function, and then we are going to get the raster extent as well here. Okay, well, this is a function that just creates a raster extent and give you back the raster extent. For example, for the model top, this is the raster extent. Okay, and this gives you some points random, but I think that this one is that this variable is not. I think that this one is not working. Okay, great. So, and then from this one, for every layer, okay, we sample from the array, and then we create a surface list. This is for every layers. However, for every two layers, okay, we are going to sample the orientations for the 2 points for the 2 identified points. Okay, great. So that's here we are sampling. Okay, and then from the sample we create a data frame. Okay, and for example, we are going to have because in order for the samples, okay, your point, I mean, the upper point has to be higher than the maximum, so it has to be higher than the maximum. So this is higher than and it has to, the bottom has to be lower than the minimum. So this is lower than the minimum. Okay, and model surface, we save that as model surface, and for the orientation, here we have the orientation, we save that as the orientation. I'm going to restart and clear our outputs and run it again. Why? Because if you remember, I have deleted a cell, so I wanted to be sure that everything runs okay if with this deleted cell. Okay, so what we have here, we have already the orientation on the surface that has been created, okay? And with that, okay, we go to with that, we go to the scripts, and then we open the visualization, okay? So if you don't have the required, the PyVista, you need PyVista Jupyter, okay? I have already, you have to run it once and then just comment it. Okay, why? Because this is for the interaction, the interactive visualization. Okay, kernel clear all outputs. Okay, so okay, it is necessary that working functions is here. Okay, so we create the data frames. We have the row size, we have the legend size, we have the plot objects. Okay. Well, there is a interactive visualization here that it seems that it's not working, but there is no problem because we just need to do the VTKs. Okay, and here on the VTKs we have the orientation of the surface. Okay, so from that we can see that in ParaView. Okay, and compare with the data. Okay, so next, okay, we are going to start working with Aquifer App. Okay, the next step is working with Aquifer App. So aquifer.hatarilabs.com. Okay, your password. Okay, and then we create a project webinar. Okay, and then here this is webinar. Okay, great. So we go to it. We are going to run Gempy, and then we create a pod. Okay, there is a question that says the point extracted in Python is in, yeah, okay, with the code that we have provided, the points are in the format required by Gempy. Okay, so we view, okay, and the values are going to be from this code. For example, okay, so in P2, so the area of interest, okay, so we have the minimum x is going to be the minimum x, the maximum x is going to be the maximum X. Okay, great. Okay, the minimum Y is going to appear here, and the maximum Y is going to appear here. And as I told you, you have to select two elevations that are higher than the maximum and lower than the minimum. These are the values. Okay, and here we are going to do 50, 50, and 75. Okay, now them data, even though that we have the them data, since we are only going to work with the from value 10 to the, yeah, from layer 20 to 30 actually. Okay, and just, okay, so let's see the orientation. Which is the orientation? The orientation is the orientation that we have created right now. Okay, that only has two values every two layers. Next, and the surface point is a surface. This has more data. Actually, there are 500 points. Okay, and then since we are defining 10 layers, okay, compile. Okay, and then we compile, and then we are here. Okay, there is only one strat, so here this is the sequence lodge. What is fine is that here you have an index, and this index is in order, so that is why we only have to put all layers in order. Doesn't take you much time. And this will be 2, 3, 4, 5, 6, 7, 8, 9, and 10. Upload. Okay, so it has recognized the points and the orientations. Okay, this is the structural frame. And then here we have the plots. Okay. Okay, so we have the x-axis, the y-axis, and as well we have here the distribution. Well, there is the distance are not the same because actually the distribution is different, but well, it works. Okay, so but our model is more complex. Okay, so because this is a containerized form and the resources, the computational resources are limited. Okay, so that is why we are going to download the project. Okay, so we download the project. Okay, let me clear my download folder. Okay, again, we download the project, and then we are going to run it locally. Okay, so here in the download project, we extract here. So it's mnt Gempy, and then we go to model data. Okay, and then we work with Gempy total script. Okay, great. So this is the Gempy generated code, where here we are. Okay, so in order to run it locally, we have to change the, so it will be gempy.log, because the path has to be defined. So for example, this will be point. This will be point. Okay, and what you have to change are marked on the code as well. Okay, for example, here you have to use this. Okay, something that you have to remember or to be aware of is that, for example, since this maybe could be that there are some thin layers, okay, the visualizations of the layers might not work, so we are going to just to delete that. Okay, and that's it. Okay, so we save it, and then we open another anaconda prompt. We do cd downloads because it's in downloads, cd mnt, cd Gempy app, cd p2 model data. If we type there, we see that the Python total script. So we do Python Gempy total script. Okay, and it will take around 3 minutes. Okay, it will take around 3 minutes. So on the recorded version, we are going to make a pause. Okay, it's done. So here we have the data. Actually was pretty intensive computationally. Okay, and we can see here on downloads we have the log file. Okay, so we have the gempy.log that we can open. Okay, and it has run in 400 seconds. Okay, sometimes it runs in, okay, it really depends on your computer. Okay, so 400 seconds is 7 minutes. Okay, so and it has created the BTKs. Okay, so the next part is on ParaView, because okay, so we close that. Where are the BTKs? Okay, the BTKs is not just the BTKs, is the geometry. Okay, so the BTKs are the geometry, is the geometry of the model. It's not a visualization. It's not only the visualization. And if, yeah, by sure there are other formats. Well, I have used BTK because it's compatible with PyVistas, but there are other formats where you can export the lithology model. Okay, so we have the lithology. Okay, great. So this will be 25. And then here we can plot the lithology and the surface. Okay, and this is the model. Okay, however, I will do a clipping. Okay, great. So here we have the clipping. We are going to invert because I want to see the other part. And then here I am going to do 25. Okay, great. So this is, here I change the scale to a scale that is here, this one. Okay, why I change the scale to this one? Because I'm going to open, okay, another VTKs. Okay, I'm going to open the VTKs of the generated VTKs of the input files. That where are these? This in here, the VTKs. So we have the surface VTK. Okay, because the orientation there are a few points. Okay, do we have the orientation VTKs? And this is also 25 because there are a lot of orientation, and the point size it will be 10, 12. Okay, so these are the contacts. Okay, and these are the generated layers. Okay, these are the contacts and these are the generated layers. But for example, if I want to see the top, the bottom of the first layer, I will need the surface one. What is the surface one? The surface one is in downloads, MNT, Gempy, image data. We have the surface 0. This is the first surface. Okay. So, and then we have also to give 25 vertical exaggeration. Okay, and this is the bottom of the first 0, and then you see how this is, does it fit. But as well, there is, if you see, there is a gap here, and this gap, I don't know what is related to, but there is a gap, and this maybe is from the interpolation, don't know. But then you can open another surface. For example, let's see surface 6. Surface 6, there is another surface that where you have 25 here. Okay, and then you can explore the fitness of the surface and the interpolation as well, no? Okay, so that will be this that will be the end of this applied case. All the files are in the description, and I hope that this will be helpful for you. My recommendations is my recommendation is to follow the tutorial, yeah, with the data, and then from that analyze how you can apply this to your own data. Okay, we are going also to provide more cases of we are going to provide as well more cases of geological modeling. Okay, a lot, because we have a lot of energy to promote the use of this platform. Thank you.